Chemistry is an experimental science. That means results must be reproducible, reliable. There are two types of numbers. Exact numbers, that's what I'm talking about, definitions. Or these are obtained known by definitions or known by counting. For example, the number of students in the class, you can count. There are no half students. The definition of 1 inch equals, or 12 inch equals 1 foot. But we also need to think about inexact numbers. These are derived by measurement. And this is what scientists do. They use many, many tools, and these have uncertainty. They are only as good as the person who is measuring and by the reliability of the equipment. The equipment contains uncertainty. It is only as precise as you want to pay for. Is inexact. All right. For example, we talk about something called significant figures. If you've noticed, if you weigh yourself at home, you may get a number like 154 pounds. We say that has 3 significant figures. But when you go to the doctor, it may read 153.8 pounds, which is 4 significant figures. All the digits are but the last you're sure of, and the final one is a guess, but it's generally a good guess with an error of plus or minus 1. Anything beyond that 0.8 is meaningless. The piece of equipment cannot measure anything below what that's called the tenths place. So if you do a calculation, you change that pounds perhaps to kilograms, the metric system, and your calculator gives you 20 numbers, 20 digits. All but 4 of those are meaningless, are worthless. And you don't want to have to write them all down, so let's figure out which are significant. Zeros are a bugaboo. So the number of significant figures are all the numbers. The 0, we have to look at 4 situations. Captured, that means the zeros in the middle, they're all significant. Leading zeros are insignificant because they're simply telling us where this little decimal point is. These are the numbers that are significant. This has 3 significant figures. Our friend here, though, if he's got a 0 to the right of the decimal point, he is significant, and this number has 4 significant figures. Trailing zeros left of the decimal point may or may not be significant. For example, this may have 2, 3, 4, or 5 significant figures. We don't know because we can't see the piece of equipment this was measured on. And this happens all the time, of course. You're reading a scientific paper, you come across a number. You need to be able to know how precise that piece of equipment was measured, could measure. What scientists will do is they will either use common sense or, better yet, something called scientific notation. And scientific notation is simply a different way of writing a number. We will take the number and transpose it into this form, where n is a number between 1 and 10. Right? So we only have a single digit to the left of the decimal point. Right? So n sits over here. Okay. Well, oh, that's not true. N, let's see, we just have a single digit between to the left of the decimal point, but we may have a whole bunch over here. All right, whole bunch of numbers over on the right side. Okay. N as the exponent tells us where to place the decimal point. If it is a negative number, we have moved the decimal point to the left, and if it's a positive number, we have moved the decimal point to the right in order to obtain our scientific notation. Okay, let's look at these two examples. 87,000. In scientific notation, we can only have one digit to the left of the decimal point. Here we go with a 7, and I'm going to tell you right now that there are only two significant figures. So I'm done. And then to tell me that it started off at 87,000, I write it how many times I'd multiply it times 10 to get the original number, and it is 1, 2, 3, 4. I'd have to multiply times 10 4 times. So this equals 8.7 times 10 times 10 times 10 times 10. What if all these were significant? That I had a piece of equipment that could read to the tens place and I estimated the ones place. I would write this as the same number here. I can only have one on this left side, but I'd have to include the zeros here. Okay? And that takes away all the ambiguity about what is a good digit and what is a placeholder. How about this one? This is when we're going to have a negative exponent for the numbers between 0 and 1. And for this guy, I would have to move over 1, 2, 3, 4. Minus 4 times 3.20. Remember I told you that if he's got a 0 to the right of the decimal point, he will be significant. Right of the number to the right of the decimal point. Okay. These are not significant. They're just holding the decimal place. And what does the negative mean? It means divide by 0. So this number would be 3.20 divided by 10 times 10 times 10 times 10. And if I did that math, I would get the long form over here.